So part one, express cos 4 theta in terms of sine 2 theta, and hence show that cos 4 theta can be expressed like that. Right, so we start with cos 4 theta in terms of sine 2 theta. Well, let's first remind ourselves quickly of our identities that we've got. If we're talking about cos 4 theta, well, we start, and you can get this from the formula book, with cos of 2a is cos squared a minus sine squared. Remember? We got that one? And that leads us to two further identities using the Pythagorean identity to switch things round. If we replace cos squared with 1 minus sine squared, we've got 1 minus 2 sine squared a. If we replace sine squared with 1 minus cos squared, we've got 2 cos squared a minus 1. So that's our options for cos 2a. But the question said cos 4 theta. So if this is going to be cos 4 theta, I'm replacing a with 2 theta. So cos 4 theta is replace a with 2 theta. We've got this one we want 1 minus 2 sine squared 2 theta. So there's our first mark out of that for writing that. And hence show it can be expressed in this form. So we've got to get this now. So it's just in terms of single thetas. Well, hang on, maybe if we're writing this, we should also remind ourselves that we know that sine 2a is 2 sine a cos a. And so actually here we've got sine squared. Let's replace that. Sine squared, hang on, what am I doing with this? Sine squared, oh yeah, let's work with that first. That's that. I know we know that, but let's just put it there like that first. So we've got 1 minus twice 2 sine theta cos theta, all squared. Now that we can deal with that squared bit now. So cos 4 theta is also 1 minus, oh, hang on, what we've got here, we've got this 2 inside the square bracket actually is a 4, isn't it? 2 squared is 4, doubled, so that's an 8 there. Then we've got sine squared theta, cos squared theta. And that matches what we were looking for with k being 8. Is that alright? The key is not getting distracted by this squared and the 2 being all in here. I think this is quite an important step, recognising that it's sine 2 theta all squared, and then doing something with sine 2 theta first. So having got that far, we've now got to do something with, hence find the exact value of sine squared 1/24 of pi cos squared 1/24 of pi. Right. Well, how can we think about this? What we've got is, we've got this expression here. Now in that expression there, we're looking for this bit, sine squared cos squared, being 1/24 of pi. So that means let's replace theta with 1/24 pi. If we do that, that means that 4 theta times that by 4, and we've got 1/6 of pi. So let's just keep working with this because we're happy with this. Sub these values into that and see what happens. We've now got, therefore, that cos 4 pi, cos pi by 6, is 1 minus 8 lots of sine squared pi over 24 cos squared pi over 24. The question wanted to know the value of just that bit there. So we're rearranging all this. We are taking the 8 sine squared pi by 24 cos squared pi by 24 to the other side to leave us with 1 minus cos pi by 6. We're talking about exact values here. Cos pi by 6, that's cosine of 30. The calculator will give you an exact value if you don't know it. It's root 3 over 2, isn't it? So we've got 8 times that. That's slightly irritating having to write it out every time. Is 1 minus root 3 over 2. So we're going to divide all of that by 8 and get our exact answer. If we divide it by 8, what we could write an 8th minus root 3 over 16, or you could put it over combination if you really want to. It's a little bit messy, isn't it? There's quite a lot of writing stuff out and potentially making mistakes. And it's all about noticing that the key to it is replacing this theta here by pi by 24, and what effect that has on cos 4 theta on the other side. I haven't tried this. If you put it into a calculator, does that give you an exact answer, or does it give you a decimal? It's quite a complicated thing to type into a calculator anyway.
Where do you get 60?
Where do I get?
60. At the top. Why do you start with
6. Sorry, that's let.
that?
There we go.
I'll draw a sound square into it.
Let theta
No, yeah.
equal pi by 24.
You get 0.0.
It gives you a
167,
decimal, does it?
yeah.
It doesn't even give you a nice answer. Oh, so I'm replacing theta with pi over 24 because the question wants me to get sine squared pi over 24 cos squared. So seeing that I've got a sine squared cos squared there, and I want them to be pi over 24. It was only 2 marks for doing that. Then finally, part 3, by expressing. Part 3 is just a real mess. This it now says. I'm going to go to a new page for this. It now says, by expressing. There it is. By expressing 2 cos squared 2 theta minus 8 over 3 sine squared theta cos squared theta in terms of cos 4 theta, find the greatest and least possible values of that. Right. That is in 2 parts though, isn't it? The thing that we're looking at here is 2 cos squared 2 theta minus 8 over 3 sine squared theta cos squared theta. Right, let's look at these one bit at a time. Let's look at this bit first, and then we'll look at this bit, and we'll see what we can do with them. By expressing them in terms of cos 4 theta. Well, let's look at the first bit. We know, we wrote this on the other side, we have the cos 2a identities, and we know that cos 4 theta is the one that we haven't used yet, says it's equal to 2 cos squared 2 theta minus 1. There's our yellow bit appearing in here. So a quick rearrangement of this identity, which we know, gives us that 2 cos squared 2 theta is equal to 1 plus cos 4 theta. Alright, so that has sorted our yellow expression in the thing that we're heading towards. Now let's look at the green bit. Now from the work that we've already done, we know that 8 over 3 sine squared theta cos squared theta, well look, 8 sine squared theta cos squared theta is equal to 1 minus cos 4 theta. So 8 over 3 times that must be equal to 1/3 of 1 minus cos 4 theta. Okay, and that's sorted the green bit in terms of cos 4 So the original expression that we're talking about, 2 cos squared 2 theta minus 8/3 sine squared theta cos squared theta, that must be exactly the same as 2 cos squared 2 theta, so 1 plus cos 4 theta minus 8/3 of all that lot, so minus 1/3 of 1 minus cos 4 theta. We can tidy this up slightly. What have we got? We've got a cos, oh wait, we've got 1 there, take away 1/3. So we've got 2/3 there. We've got a cos 4 theta minus 1/3 times minus cos 4 theta. So cos 4 theta plus 1/3 of cos 4 theta. Okay, and the question was asking us, what is the greatest and least value of this? Well, in this, the bit that varies is cos 4 theta. The fact that it's 4 theta is irrelevant. Cos of something goes between plus or minus 1, doesn't it? So that bit there, the least value that that bit takes, that's the only bit that varies, its least value is minus 1. So the least value is when cos 4 theta equals minus 1, and so the least value is 2/3 minus 4/3, so it is minus 2/3. And the greatest value must be when cos 4 theta takes its greatest value, which is plus 1. And that would be 2/3 plus 4/3, which is 6/3, so 2. So they're the values that we're looking for. That's a reasonably common thing, isn't it? That's a write this expression involving some trig functions and then talk about when it has its least or most values. What was the greatest and least possible values as theta values? Thanks, Dan. Have you stopped it? No.
Try.